Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters. So I'm going to show you the given differential equation. Solving the differential equation in three ways using variation of parameters method in three parts. Okay. So in this video, we are going to see part 1. So let's get going. Problem solve y double dash plus 4y equal to tan square 2x or d square plus 4 into y equal to tan square 2x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus 4y equal to tan square 2x, or you can write y double dash as d square y by dx square, that is double derivative of y with respect to x, plus 4y equal to tan square 2x. Now we can write d square y by dx square in operator form, say d square, capital D square y plus 4y equal to tan square 2x. Okay, now take y common from these two terms, we'll get d square plus 4 into y equal to tan square 2x, which is in operator form. Now consider the given differential equation as equation 1 and the equation in operator form as some equation 2, right, which is in operator form, say f of d into y equals to some function of x where f of d is d square plus 4, and the homogeneous equation of equation 2 will be d square plus 4 into y equal to 0. Consider it as equation number 3. Now we need to find the solution of the homogeneous equation or equation 3 using the auxiliary equation, and later we'll find the solution of equation 2 using the solution of equation 3 here. Okay. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d square plus 4. Let's replace differential operator with m, so that we'll get f of m equal to m square plus 4, and the auxiliary equation becomes m square plus 4 equals to 0. Now we need to find the roots of this equation, so we'll take this 4 to RHS, we'll get m square equals to minus 4, and we can write m equal to plus or minus square root of minus 4, right? Minus 4 as minus 1 into 4. Now we'll split the square root to square root of minus 1 into square root of 4. Since we know that square root of minus 1 is I, so let's replace square root of minus 1 with I and square root of 4 with 2. Therefore, m equal to plus or minus 2i, I2 is a pair of complex conjugate roots. The roots are complex conjugate. We know that when two roots are complex conjugates, say if m equal to a plus or minus ib, then the solution of the homogeneous will be y equal to e power ax into some constant into cos bx plus another constant into sin bx. Okay. See, here I am taking C3, C4 instead of C1, C2 or A, B or anything else, because I wanted C1 and C2 in the last general solution. I want to appear C1 and C2 in the general solution. So I am taking C3 and C4 instead of C1 and C2, right? In case of A equal to 0, we'll get e power 0 into x, which is equals to e power 0 into C3 cos bx plus c4 sin bx. Since e power 0 is 1, so this becomes 1 into c3 cos bx plus c4 sin bx, which is equals to c3 cos bx plus c4 sin bx, right? Now compare plus or minus I2 with plus or minus IB, then for b equals to 2, we'll get the solution of the homogeneous equation. The solution of the homogeneous equation, that is equation 3, is y equal to c3 cos 2 into x plus c4 sin 2 into x, or y equal to c3 cos 2x plus c4 sin 2x. We got the solution of homogeneous equation, right? Now let y equal to, just replace constant c3, c4 with a and b functions of x. We'll replace the constants or parameters with functions of x, a and b. Then we'll get y equal to a cos 2x plus b sin 2x. B, the general solution of 1 or 2. Both are same. Okay, this is an operator form of equation 1. Okay, so now, okay, where a and b are functions of x, let's now find y dash and y double dash. Firstly, we'll find y dash. We are having y equal to a cos 2x plus b sin 2x, right? Now we need to find y dash, that is derivative of y with respect to x. This is equals to a cos 2x whole dash plus b sin 2x whole dash. Now we are going to use uv whole dash formula. Uv whole dash equals to u dash v plus v dash u. Let's apply the formula. We'll get a dash into cos 2x plus a into derivative of cos 2x with respect to x plus b dash into sin 2x plus b into derivative of sin 2x with respect to x. This is equals to a dash cos 2x plus a into derivative of cos 2x with respect to x is minus 2 sin 2x plus b dash sin 2x plus b into derivative of sin 2x with respect to x is 2 cos 2x. Right? This becomes a dash cos 2x plus into minus minus 2a sin 2x plus b dash sin 2x plus 2b cos 2x. Let's now write the terms involving a and b. We'll get minus 2a sin 2x plus 2b cos 2x. Now write the terms involving a dash and b dash. We'll get plus a dash cos 2x plus b dash sin 2x. Now put a dash cos 2x plus b dash sin 2x equals to 0. Let a dash cos 2x plus b dash sin 2x equals to 0, so that while finding derivative of y dash, a double dash and b double dash will not appear. Okay, if we put this term equals to 0, then we'll get y dash equals to minus 2a sin 2x plus 2b cos 2x plus 0. From this we'll get y dash equals to minus 2a sin 2x plus 2b cos 2x, right? And let this equation be some equation number 4. We'll use this later for finding a dash and b dash values. Okay, now we got y dash and we need to find y double dash. We have y dash equals to minus 2a sin 2x plus 2b cos 2x, right? We need to find y double dash here, that is derivative of y dash, which is equals to minus 2 into a sin 2x whole dash plus 2 into b cos 2x whole dash. Here also we'll find uv whole dash formula. This is equals to minus 2 into, consider a as u and sin 2x as v, will get a dash sin 2x plus a into sin 2x whole dash plus 2 into b dash cos 2x plus b into derivative of cos 2x with respect to x. This is equals to minus 2 into a dash sin 2x plus a into derivative of sin 2x with respect to x is 2 cos 2x plus 2 into b dash cos 2x plus b into derivative of cos 2x with respect to x is minus 2 sin 2x. This becomes minus 2 into a dash sin 2x plus 2a cos 2x plus 2 into b dash cos 2x minus 2b sin 2x, right? This is equals to minus 2a dash sin 2x minus into plus minus 2 is a 4a cos 2x plus 2b dash cos 2x plus into minus minus 2 is a 4b sin 2x. So we got y double dash and we are having y and y dash. Let's now substitute y double dash and y in equation 1. Here we said that y equal to a cos 2x plus b sin 2x is a solution or general solution of equation 1, right? Then y should satisfy that equation. So that's the purpose why we are substituting y dash and y here. Okay, that's how we are substituting here. In order to find a dash and b dash, we'll substitute y and y dash in equation 1 because y is a solution of equation 1, right? Fine. Now let's substitute y double dash and y in equation 1. What is equation 1? We have equation 1 y double dash plus 4y equal to tan square 2x, right? Let's substitute y double dash and y here. Y double dash is minus 2a dash sin 2x minus 4a cos 2x plus 2b dash cos 2x minus 4b sin 2x plus 4 into y a cos 2x plus b sin 2x equal to tan square 2x, right? This from this we'll get minus 2a dash sin 2x minus 4a cos 2x plus 2b dash cos 2x minus 4b sin 2x plus 4a cos 2x plus 4b sin 2x equal to tan square 2x, right? So here minus 2a cos 2x plus 2a cos 2x gets cancelled, and minus 4b cos sin 2x and plus 4b sin 2x gets cancelled. We'll get minus 2a dash sin 2x plus 2b dash cos 2x equal to tan square 2x. Consider it as equation number 5. Now we'll solve equation 4 and equation 5 to find a dash and b dash. Okay, let's solve 4 and 5 now. We have equation 4 and 5. A dash cos 2x plus b dash sin 2x equals to 0 is our equation 4, and minus 2a dash sin 2x plus 2b dash cos 2x equal to tan square 2x is our equation 5. Now in order to solve these two equations, observe the first term in both the equations, or first term of both the equations. We have a dash cos 2x in equation 4 and here minus 2a dash sin 2x, right? So in order to cancel and in order to get b dash, we need to cancel these two, right? In order to cancel these two, we need some 2 sin 2x in this term, and here we need some cos 2x. So we'll multiply 2 sin 2x to equation 4 and cos 2x to equation 5. Then we'll get 2a dash sin 2x into cos 2x plus 2 sin 2x, or 2b dash sin 2x into sin 2x is sin square 2x equal to 0. Now multiply this term with, this equation with cos 2x, will get minus 2a dash sin 2x into cos 2x plus 2b dash cos 2x into cos 2x is cos square 2x equal to tan square 2x into cos 2x is tan square 2x cos 2x, right? Now we can cancel 2a dash sin 2x cos 2x and minus 2a dash sin 2x cos 2x, and here we'll get 2b dash sin square 2x plus 2b dash cos square 2x equals to tan square 2x into cos 2x, right? Let's now take 2b dash common from these two terms. We'll get 2b dash of sin square 2x plus cos square 2x equal to, we can write tan square 2x as sin square 2x by cos square 2x into cos 2x, right? Or instead of replacing tan square 2x with sin square 2x by cos square 2x, we can replace it with secant square 2x minus 1. Since tan square 2x equals to, or 1 plus tan square theta equal to secant square theta, then tan square theta equal to secant square theta minus 1. Okay, if you replace tan square 2x with sin square 2x by cos square 2x, we'll just get sin square 2x by cos square 2x into cos 2x, which is equals to sin square 2x by cos 2x. Again we can replace sin square 2x with, since sin square theta plus cos square theta equal to 1, from this we'll get sin square theta equal to 1 minus cos square theta. So we can replace sin square theta with 1 minus cos square theta. From this also you'll get, from this we'll get 1 by cos 2x minus cos 2x. Okay, we'll get the same thing. You can use any of these two here. Instead of replacing tan square 2x with secant square 2x minus 1 or sin square 2x by cos square 2x, let's write as it is. Okay, we'll see this later. This becomes 2b dash into sin square 2x plus cos square 2x is 1. Since sin square theta plus cos square theta equal to 1, you'll get into 1 equal to tan square 2x into cos 2x. From this we'll get 2b dash equal to tan square 2x cos 2x. From this we'll get b dash equal to 1 by 2 tan square 2x into cos 2x. Okay. Now we got b dash equals to 1 by 2 into tan square 2x into cos 2x, right? If 1 plus, or if we want to replace tan square with secant square in terms of secant, we'll just use 1 plus tan square 2x equals to secant square 2x, and from this we'll get better. I'll use theta. Tan square theta equal to secant square theta minus 1, or we can just write tan theta is sin theta by cos theta, or tan square theta can be replaced by sin square theta by cos square theta. Okay, so let's see in both the cases. If tan square theta equal to secant square theta minus 1, then b dash becomes 1 by 2 into secant square 2x minus 1 into cos 2x, right? This is equals to 1 by 2 into secant square 2x into cos 2x minus cos 2x, right? Now we can write secant square 2x as secant 2x into secant 2x into cos 2x minus cos 2x. Okay, since we are having cos 2x, and we can write secant square 2x as reciprocal of cos 2x, and secant theta equal to reciprocal of cos theta. Then we'll get 1 by 2 into, I'll replace 1 secant 2x with reciprocal of cos 2x, so that I can cancel cos 2x here. So from this we'll get b dash equals to 1 by 2 into secant 2x minus cos 2x. Okay, now let's see what happens if we replace tan square theta with sin square theta by cos square theta. Then b dash becomes 1 by 2 into sin square theta by cos square theta into sin square 2x by cos square 2x into cos 2x. If 1 cos 2x gets cancelled, we will get 1 by 2 into sin square 2x by cos square 2x, which is equals to 1 by 2 into, since sin square theta plus cos square theta equal to 1, from this we'll get sin square theta equal to 1 minus cos square theta, right? So let's replace sin square 2x with 1 minus cos square 2x. We'll get 1 minus cos square 2x by cos 2x here. Now you are having 2 terms in the numerator and 1 term in the denominator, so we can split this into 2 terms. We'll get 1 by cos 2x minus cos square 2x by cos 2x, right? This is equals to 1 by 2 into reciprocal of cos 2x is secant 2x minus, if 1 cos 2x gets cancelled, you'll get cos 2x. We'll get the same thing. Okay, either you can replace tan square theta with secant square theta minus 1, or tan square theta with sin square theta by cos square theta. So finally we got b dash. Therefore b dash equals to 1 by 2 into secant 2x minus cos 2x. Therefore, b dash equals to 1 by 2 into secant 2x minus cos 2x. We got b dash, right, by solving 4 and 5. Now let's put b dash in equation 4. We have equation 4, a dash cos 2x plus b dash sin 2x. Let's substitute b dash here, then we'll get a dash cos 2x equal to, firstly I'll take this to RHS, okay, I'll get minus b dash sin 2x. Now I'll substitute b dash here. Since b dash equals to 1 by 2 into secant 2x minus cos 2x, we'll get a dash cos 2x equals to minus 1 by 2 into secant 2x minus cos 2x into sin 2x, right? Now take this cos 2x, it's 2x, right? Take this cos 2x to RHS, then we'll get a dash equals to minus 1 by 2 into secant 2x minus cos 2x into sin 2x by cos 2x, okay, is equals to minus 1 by 2 into secant 2x into sin 2x by cos 2x minus cos 2x into sin 2x by cos 2x. In the second term, cos 2x gets cancelled, and here we can replace sin theta by cos theta with tan theta, since sin theta by cos theta equal to tan theta. So we'll replace it with tan. We'll get 1 by 2 minus 1 by 2 into secant 2x into tan 2x minus sin 2x, which is the required a dash. We got b dash and a dash, right? Since y equal to a cos 2x plus b sin 2x is general solution of 1, so this satisfies this equation. That's the reason we have substituted y dash and y in equation 1, and from that we got a dash and b dash by solving the result obtained by applying y and y dash in equation 1 and equation 4, right? Till now we just applied y and y dash. I mean, we have substituted y and y dash in equation 1 to find a dash b dash, right? Now using this a dash and b dash, we'll find a and b. So firstly I'll go for a dash. We have a dash equals to minus 1 by 2 into secant 2x tan 2x minus sin 2x. We know that a dash is derivative of a with respect to x. RHS remains the same. Now let's separate the variables. In order to separate the variables, we'll take the differential dx to RHS, then we'll get dA equal to minus 1 by 2 into secant 2x tan 2x minus sin 2x into dx, right? Here the variables are separable. So we can perform integration. Integral dA equal to minus 1 by 2 integral of secant 2x tan 2x minus sin 2x into dx. From this we'll get integral dA equal to minus 1 by 2 into integral secant 2x tan 2x dx minus integral sin 2x dx, right? Since we know that integral secant a theta tan a theta d theta equal to 1 by a secant a theta and integral sine a theta d theta equal to minus 1 by a cos a theta. So by applying this formula we'll get a here. This becomes integral dA a equal to minus 1 by 2 into integral secant 2x tan 2x dx. For a equal to 2 we'll get 1 by 2 into secant 2x minus integral sin 2x dx. For a equal to 2 we'll get minus 1 by 2 into cos 2x plus some integral constant, say c1. This is equals to minus 1 by 2 into 1 by 2 is 1 by 4 secant 2x minus into minus plus plus into minus minus 1 by 2 into 1 by 2 is 1 by 4 cos 2x plus c1. So we got a here. Let's now find b using b dash. We have b dash equals to 1 by 2 into secant 2x minus cos 2x. We know that b dash is derivative of b with respect to x. Now we need to separate the variables. So we'll take the differential dx to RHS and we'll get db equal to 1 by 2 into secant 2x minus cos 2x into dx, right? Here the variables are separable. So we can perform integration. Integral db equal to 1 by 2 integral secant 2x dx minus 1 by 2 integral cos 2x dx. Right? Since we know that integral secant ax or a theta equal to 1 by a log mod secant a theta plus tan a theta, and integral cos a theta d theta is 1 by a sin a theta. Then this becomes integral db b equal to 1 by 2 into integral secant 2x dx. For a equal to 2 we'll get 1 by 2 into log mod secant 2x plus tan 2x minus 1 by 2 into integral cos 2x dx. For a equal to 2 we'll get into 1 by 2 into sin 2x plus integral constant, say c2. Then b equal to 1 by 2 into 1 by 2 into 2 to the 4, 1 by 4 log mod secant 2x plus tan 2x minus 1 by 2 into 1 by 2 is 1 by 4 sin 2x plus c2. This is our required b. We got a and b. Let's now write the general solution using y equal to a cos 2x plus b sin 2x. Therefore, the general solution of the given equation 1 or 2 is given by y equal to a cos 2x plus b sin 2x. Let's now substitute a and b here. We'll get y equal to a minus 1 by 4 secant 2x minus 1 by 4 cos 2x plus c1 into cos 2x plus b 1 by 4 log mod secant 2x plus tan 2x minus 1 by 4 sin 2x plus c2 into sin 2x. We'll get minus 1 by 4 secant 2x into cos 2x minus 1 by 4 into cos 2x cos square 2x plus c1 cos 2x plus 1 by 4, this term into sine 2x is sine 2x, log mod secant 2x plus tan 2x, minus 1 by 4, sine 2x into sine 2x is sine square 2x, plus c2 sine 2x. Okay. Then general solution will be y equal to 1 by 4. Here we are having secant 2x into cos 2x, right? We can write secant 2x as reciprocal of cos 2x, so we'll get 1 by cos 2x here into cos 2x minus 1 by 4 cos square 2x, it's 2x, plus c1 cos 2x plus 1 by 4 sin 2x log mod secant 2x plus tan 2x minus 1 by 4 sin square 2x plus c2 sin 2x. So here cos 2x gets cancelled from the first term. Then we'll get y equal to minus 1 by 4. Now take minus 1 by 4 common from these two terms. Then we'll get minus 1 by 4 into sin square 2x plus cos square 2x plus c1 cos 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x plus c2 sin 2x. This becomes minus 1 by 4 into sin square theta plus cos square theta equal to 1. So from this we'll get sin square 2x plus cos square 2x equals to 1 plus c1 cos 2x plus 1 by 4 sin 2x log mod secant 2x plus tan 2x plus c2 sin 2x. This becomes minus 1 by 4 into minus 1 by 4. Okay, and remaining will be as it is. Minus 1 by 4 minus 1 by 4 is minus 1 minus 1 by 4 minus 1 by 4 is minus 1 minus 1 by 4, which is minus 2 by 4. Okay, is equals to minus 2 by 4, which is minus 1 by 2. So let's replace minus 1 by 4 with minus 1 by 2 here. Remaining terms will be the same. This is the required general solution, or we can write it as, write the terms involving c1 and c2 firstly. We'll get c1 cos 2x plus c2 sin 2x plus 1 by 4 sin 2x into log mod secant 2x plus tan 2x minus 1 by 2. This completes the problem. So we have seen a problem from variation of parameters method in this video using part 1, and you will see the other two ways in part 2 and part 3. So we'll see you in the next video. Until then, bye bye.